there are some very specific differences between intellectual property and the rights that attach to the intellectual property. The rights are given by a government. They're granted by the state in different countries around the world. So the rights are property rights that attach to the intellectual property. So the intellectual property per se is the knowledge and skills and output, but the rights are property rights that attach to that. That's intangible. You can't touch knowledge like you can touch a car or an assistive mobility or a cooling vehicle, a battery cooling thing. That's tangible. You can touch it. Intellectual property is not tangible. It's intangible. You cannot touch it. But you can still get property rights around that intangible intellectual property outputs. And those property rights give you legal protection. So it's a difference between science in this case and law. The rights are the law. The intellectual property rights are the law. The intellectual property is the science that comes out of your heads. Okay, so they're different things. And what the legal protection affords you is a way to protect how it's used. There's trademarks like Coca-Cola, and University of Moratuwa probably has its own trademark. Lots of trademarks. This one on this slide, Eclipse, that's my trademark. That's my business trademark. So lots of things have trademarks, and that's a form of intellectual property. Copyright, so I said before, the copyright in these slides that I put together, that belongs to me. Designs, plant breeders' rights. You're in a country that's got a lot of agriculture, so you might know about plant breeders' rights as well. In the semiconductor industry, electrical circuit layouts, the way they're laid out, the physical way that they're laid out, they can be inventions, and of course patents. These are all granted except copyright. Copyright is a bit different in that it exists automatically. There's copyright in all of these slides just because I wrote it down. The way I did it, the branding, the way I've used these blue and white lines across here and across there, the logic of the way that the layout, you know, the title here and the bars there and my logo down here, that layout and the color scheme, all of that, there's copyright in that because I wrote it down and did it that way. And you don't have to register that. But all these others, trademarks, designs, PBR, layouts and patents, you have to get grants of rights for that. You have to register those things in different countries one by one. They don't exist automatically. The one we'll talk about now is patents. So all of these are granted by the government. So a patent is a statutory grant of rights. Do you know what a statute is? An act of parliament. Do you know what acts of parliament are? Nod or shake your head. No? So you know Parliament creates the laws, right? So if you commit a crime, you would be breaking the law, right? Understand? Yes or no? Nod or shake your head. Yes, you understand?
Yes. Yeah.
So the law that you're breaking is written down somewhere. It's not just made up in the air. It's written down in a document that's created by the Parliament. And that document is an act of the Parliament. I think it's probably the same in your country. It's certainly like this in all of Europe, all of the civil law across Europe, the UK and Australia and Africa and US. We all have acts of Parliament. And these acts set out what you can and can't do. And if you break the law, you break the law. And if it says in the criminal code you can't kill somebody and you kill someone, you've broken that law. That's in the Criminal Act, Crimes Act. You probably also have. And there's a Patents Act and a Trademarks Act and a Copyright Act. All these things are statutes. That's what they're called. So this is a statutory grant of rights. It just means in accordance with the statute, the act, you get granted rights by the government through, in your case, the Intellectual Property Office of of Sri Lanka. I don't know what it's called.
Yeah, National Intellectual Property of Sri Lanka.
Okay. And this grant entitles the owner of the rights to stop other people exploiting the invention. You can stop somebody else. That's an important concept. You cannot go out and practice your invention. And I might explain about that why later if we have time. But lots of people can have grants of rights. And if there's any overlap between what you do and what somebody else is doing, they can also stop you. So if you need to do something in your invention that relies on a piece that somebody else has a patent for, then you can't go out and positively make your invention because you infringe this guy's patent, right? It's like a Venn diagram, 2 circles and they overlap. The bit in the middle, you both have. So if this guy has a patent for that and you're using it in yours, even though you've got something else that's new, if you're using that piece and they've got a patent for it, then they can stop you. So that's why it's called freedom to operate. So I wasn't going to go into this in much detail, but very fundamentally, you can't practice your invention unless you have freedom to operate, which means you're not infringing somebody else. So the patent gives you the right to stop other people. You can stop somebody else. They can all stop everybody. And if you want to practice yours, you have to make sure that by doing so, you're not going to be stopped by somebody else because of any overlap. Okay, is that clear? It's not too difficult a concept really, but sometimes people get tripped up by it. Is that okay? Okay, good. So this is called a negative right. It's not a positive grant. It's a grant that allows you to stop people. So in the patent, you get a bunch of things. And when you get the grant, we'll talk about the process shortly. When you get a patent granted, they will send you a thing called a deed of letters patent. And that confers the legal right. That piece of paper that the government sends to you is the document that says to you, you have the right, the legal rights given by the government. And it's very pretty and it's written in fancy script and it's got a big seal on it, usually a different color, and it's signed by the patent office. And the first time you get it, one is very exciting and you usually want to frame it and hang it on the wall because it's a good thing to get, right? It takes a long time and it's exciting when you get a grant of the patent. But you don't get it very quickly. It takes a long time. And to get it, you have to go through the process. And you won't get it unless you define it properly. So in a patent, the actual document that defines the invention consists of a specification wherein you disclose and describe in great detail what your invention is, and the claims at the end, wherein it describes the area that the government is saying you can stop other people from standing on. Sorry, my cat's trying to get in front of it. You can't sit there. Say hello to all the people. Say hello. Say hello. Now go down there. You can't sit there. You can't sit there. Down you go. Sorry. Okay. So the claim is like and when you go out on the land and you find the territory where you think you can find gold or copper or whatever it is, and mining companies put stakes in the ground, they literally stake out the ground. This is the area within which we claim the right to mine. And they put signs up that say trespassers will be prosecuted. Okay, that means nobody can stand on the land. If you come on this land and you're not authorized, we will take you to court. We will sue you. We will prosecute you through the legal system. So the claims at the end of a patent are a set of sentences that describe the patent territory. Just like a mining land claim, you have a patent claim around this area of science, and it's within that area that the claims define that you can stop people using it, exploiting it. Is that clear? So that's what the claims are. So it's a legal thing. This part, the specification, the disclosure for inventions is generally very technical, scientific, engineering, very precise, but the claims are legal because the issue of infringing the claim is one that the law or the court, if you're taken to court, will look at and to figure out and define what do those claims mean. What is the territory that the Intellectual Property Office granted you rights to? And is somebody else standing on those rights? So it's legal, whereas this is more science. Okay? So in the document, the actual patent document, you have sections. The claims are at the end. At the beginning, you have a cover page, which describes a lot of administrative things like the university that's applying or the person that's applying and the date that you applied. Lists some of the prior art sometimes. It will give the names of the inventors. It's basically got a lot of data on the application on the front page. Then you have the specification. So this is the legal scientific disclosure. And it's sort of like a manuscript, but there's some very key differences, which I will explain. You have to disclose how to make the invention. So there's a lot of science and there's lots of drawings and figures, data, whatever data you have, such as what you showed me that helped a lot in understanding the mobility platform. The diagrams, right, the figures that are scientific or technical, and they explain the invention and how it works. And the specification is in words, discloses what the invention is and how it works and why it's better than everything else. So you basically have to set out an expose of the invention and how it works, just like you would in a manuscript for publication, with even more data. And but the thing about this initial bit, I'll talk about it on the next slide. Then you have an abstract, which is exactly like a manuscript, just a summary of the invention in an abstract. Quite short, usually. Sometimes it's only 2 sentences. And the claims at the end, we talked about the claims already. So the cover page is just administrative stuff. The claims is the legal part. This part is the scientific stuff. And it's a bit like a manuscript, but not quite the same. And it's definitely written differently than a manuscript. If you read a couple of patents, get some US patents or some European patents and read them and see, you'll see what I mean. It's not like a science manuscript at all. The examples are, they're very technical and very scientific. And in a lots and lots of description about what you do and how you made it. So the specification, now we're just talking about this part in here, right? This specification with the drawings and the abstract, that comprises several parts. The background of the invention is the first part, and it's sort of like the background in a manuscript. But it is, you probably wouldn't put as much in it as you do in a manuscript. You don't want to put too many details about what's in the prior art, but you do want to disclose and explain what is the prior art that's closest to what you have. So you would explain some things that are assisted mobility platforms or that are hybrid electric vehicle cooling systems, and talk about in the background why they're not very good. What's undesirable about them? What is it about those things that don't quite work as well as one would like it to work? And therefore, there's a problem. And you are going to provide with your invention a solution to that problem. So that's what the background is. The background describes the closest things and what's not that great about them, so that you can then say, therefore, it would be desirable to have something which did this. So for the assisted mobility thing, it would be desirable to have a platform upon which things could be moved up and down stairs in a stable, comfortable manner, because the prior art does not solve that problem. Now, here's my invention. I'm going to summarize my invention. And in the present invention, we have done this, this, and this, which overcomes a problem. Understand? So that's what the summary does. Now, in this part, this is where you specify what the invention is. The summary of the invention is a legal part. And the legal part really is a recitation of all of the things that eventually become the claims. So it's a little bit abbreviated, but it's a summary. It's a summary of the key things about the invention, and those key things become the claims. There's two reasons for that. The first reason is because you want to summarize for the reader what the invention is before you go into this detailed description of how to do it. Okay, so that's an obvious thing that you would like to do. Just here's a summary of what we've done. Now, here's how you do it. The second reason for this summary, and the reason that it's the same as the claims, is because the claim that you get after you go through examination has to be commensurate with, in line with, supported by what is disclosed in the specification. You cannot get a claim to something that is more than you have invented. It has to line up with the extent of your invention. The scope of the invention cannot be more than you have invented. Therefore, when you put the claims in at the beginning, you try to make the language and the scope that you're claiming be what is in the specification. So if you have the same summary in the specification, then you definitely have support for the claim because it's in there in that same scope. So at least at the beginning, you're starting with a description which summarizes the scope of what you think you've invented. And those claims then go in the claims at the end. So you've got support for those claims because it's word for word the same in the specification. This is very good drafting practice. And I noticed in Southeast Asia, most patents that I've seen from my mentees don't do it. So it would be very good to read, if you want to file something internationally, read some international patent documents, read some PCTs, go on the WIPO site and find a bunch of PCT documents and read them and look at the summary. They're all got headings. There'll be a heading that says background. There'll be a heading that says figures. There'll be a heading that says summary of the invention and one that says detailed description, or very similar words that mean that. So you can look at the summary of the invention and you can look at the claims and you can see how well they match. It's a good idea to read some patents from other countries, especially if you want to file internationally. Because if you don't get your patent specification drafted in an internationally acceptable format, you are on the back foot before you even start, right? So then after that, you have the detailed description. So here you've got a general explanation of what you've made and how to make it. And you have to describe the key things that make this inventive and novel, because if it's not inventive and novel, you're not going to get a patent, okay? So there are some key things that you have to say must be included in this invention, but there'll be lots of other things that don't have to be like that. Lots of other pieces can be anything. So usually you describe the other things as well, and you can say it could be done this way, or on the other hand, it could be done this way. And somebody skilled in these sorts of things will understand that there are lots of different ways to do this part. Okay, but this key part has to be there like this, and this is how you do it. And then you have specific examples. So in the case of the assistive mobility thing, there are loads of diagrams, which some parts sent me that in the patent, that show what it looks like. What does one of these, you call them arms. I was very confused about arms because to me they're like legs. They're the things at the bottom that the thing sits on. Okay, so the things that touch the ground that help this thing to move down the stairs. And there are a bunch of them and they all work. There are three sets of two, forward, middle and back. And they move in different ways to help this thing move downstairs and keep the platform comfortable and safe. So those are specific examples with specific diagrams that describe actually what you've made. But you don't want to be necessarily limited to exactly that, because some things around that could be different and still be okay, as long as they have the key things that make it inventive. The key things of your invention have to be in the claim, and they have to be in the first claim, and they have to be described here and be in the specific examples. Okay, so this is really the scientific examples like you would describe in your manuscript. where you talk about what the invention is generally, and then you have, like you would have materials and methods and results in a manuscript. This is what I used, this is how I did it, and here's the result that I got, and here's the picture. Okay, that's the science part. And then, as I mentioned already, you have the claims at the end. And the claims very much match this at the start. They might not match that by the time you've been through examination, because you asked for this and you might only get this much. But at the start, when you draft the specification, this summary should look very similar to these claims. And the claims do this. This is legal jargon, and it's from US jargon, but it's the same in every country. They have to particularly point out and distinctly claim the subject matter that you think is your invention. And these points are important because it has to be clear. It has to be particularly pointed to, and it has to be clear. And the way the language is written has to be unambiguous. And that's something that patent attorneys train a long time to learn to do. You can't describe thing in one claim with one word and then use a different claim in the next, a different word in the next claim if you're referring to the same thing. It has to be the same language so that this is referring back to that, and it's very clear what is intended, because the claim has to describe the scope. For misunderstanding about where that boundary is. So that's why it's very important how the claims are written. And of course, if the claims are going to be the same in the summary when you started here, then you want the patent attorney or the draftsman to know exactly what this invention is, exactly what you want to have claimed, and to make sure that that language is in here at the beginning. And then you have the scientific description. So each claim is only one sentence. It might be very long. It might take up half a page, but it's still only one sentence with one capital letter at the beginning and one full stop at the end. Lots of commas and semicolons and maybe A, B, C, D and little 1, little 2, little 3 as subparts of it. If it's a method, you can have the steps comprising A, B, C, D, E, but it still has to be just one sentence. And you start with an independent claim. This is the broadest description of what you think your invention is. And underneath that, claims 2, 3, 4, etc., they are dependent claims. So they start from the first one and they say the same invention is in one, but with this additional added feature. Okay, so each 2, 3, 4, 5 depends from the first one or from the one before it, not necessarily from claim 1. You might have claim 2 that depends from claim 1, and then claim 4 might go back to claim 2. So it's the broadest invention with this claim 2 feature in it, and then add another feature that's in claim 4. So all the way down, you're getting narrower and narrower to something which is usually what you've made. But you want to claim broader than that, okay? So that's how the claims work, and they define, at the beginning, they define what you want, but at the end, they define what the state, the government, whether it's Sri Lanka or Thailand or Australia or New Zealand or US or Europe, what each government is prepared to grant as the protected area, the scope of the claim. And you get that by negotiating with examiners in the patent office. You don't get it by saying, that's what I want, give it to me. You get it by putting it in and hoping that there's no prior art that will get in the way, and that when the examiner says, here are 6 pieces of prior art that stop yours from being novel and inventive, you will be able to argue against it and get language that the examiner says is in line with what you've invented. That's what you get. And usually you ask for this and you get this. Sometimes you don't get anything. Sometimes it's too hard. The examiner comes up with too many prior art documents that are too close to your invention, so that the combinations of them mean that it's not inventive. And no matter how hard you try to explain and argue that it is inventive because of this, this, and this, the law may not be on your side, so you might not get it. Okay, but we try. Of course we try. So the claims define what the government is prepared to grant as the protected area, and you get that by negotiating with examiners. And what you get in return for a public disclosure. So this is very important. Eventually, at 18 months after you file, your patent application is published. It is a requirement to disclose to the public because that's the deal with the government. I will tell the world how to do this in return for you giving me the right to stop them for 20 years. And if they want to, they have to come to me and they have to pay me royalties. They have to get a license because the patent grant allows you to stop other people, remember? It's not a positive grant, it's a negative right. You can stop other people. So the grant that you get in return for disclosing to the world how to do this is the right to stop other people from doing it, doing what's in the claims, not what's in the document, doing what's in the claims for 20 years from the filing date. So you then have to find somebody who actually wants to practice it for 20 years from the filing date and is prepared to pay you to do that. Otherwise, it just sits there as a document that nobody ever uses. It's a waste of money, right? So you really want to find somebody to work the invention because otherwise it's a waste of time doing it. But that's what you get. In return for disclosure, you get this right to stop people for 20 years. So how do you get it? You have to meet all these criteria, and we'll talk more about this in the seminar for next month. Okay, so this is just a one-slide summary, and more about this I'll talk about next month. It has to be by nature something which is allowed to be patented, and some things are not allowed to be patented. You can't have a patent for E equals MC squared. Okay, that's a law of nature. Some things are discoveries, but they're not inventions. So it has to be patentable by nature. And then you have to meet these hurdles. It has to be novel, which means it's not published anywhere, ever, in any language, in any country before the file date, right? It doesn't just mean quirkily different, as in, you know, this is a novel way to do this. There's multiple other ways, but here's a new other different way. It doesn't mean that. It means not known, brand new, disclosed for the first time in this patent specification. And it has to be inventive, which basically means not obvious. Not obvious to people working in your field. Oh, well, that's just a tiny weeny bit, incremental. I've seen that and I've seen this do that, so it's obvious to take that and put it with this. That's not an invention. It's not a big enough step up from what is already known. Okay. And the law about obviousness is different in different countries. The amount of step is different in different countries. How it's interpreted is a bit different. So it's always the hardest one. You can have things that are novel and you'll lose the patent and won't get it because the examiners say it's not inventive enough. So this is, you know, it has to be an invention. So how much different than the prior art does it have to be before the examiner will say, okay, that's an invention? Right? This is always the hardest. Usually, inventions are commercially useful because you don't file it unless it is. But sometimes some things are filed too soon, especially in the biosciences, and they're really only discoveries or mechanistic understanding of how biology works, right? That's not really an invention. In your field, it's a little bit easier because you're making stuff. So you're actually making a prototype of something that can be made thousands of times and used. So as long as somebody wants to use it, it's commercially and pay for it, then it's commercially useful. And then, as I said before, you have to provide this full detailed description of the best way to do it. And the applicability, what is it applicable for? What can you use it for? How does it, what was that problem again? And how does this solve it? How am I going to use this in what spheres of art or spheres of science to solve this problem that existed before, which now my invention fixes? And then you have to show examples that demonstrate that you have fixed it. This is how it works. You do this, it works every time. You build this hybrid electrical vehicle cooling system like this, retrofit it to any vehicle, and it will work every time. No matter what you put it with, it will work to keep the temperature at the right temperature range. It has to work every time. It has to be validated. You can't have variability in a patent, not like in science. It's more like engineering, more precise, like the sorts of things you guys do. Okay. So then how do you get it? So that's what it has, the criteria it has to meet. So you can't get it unless it meets these criteria. And then you have to go through this process. So it's a process that takes a long time. You don't just file an application and get a grant a week later. You draft the specification the way I described before, that document, and then you go through this process. And as you can see, this is time. So this is already here, 2.5 years. And you haven't even started examination yet in the patent offices, wherever you want to go. And that also takes time. It can easily be 5 years from time zero when you file your application until you know if you've got a grant. Some countries are faster than others. Some countries have a backlog, so they take a very long time. Okay, Japan is pretty slow. Sometimes it varies. The US was very slow for a long time, and then they hired more examiners and they got a bit quicker. They caught up. So it's variable, but it takes time. It doesn't happen overnight. So this first part here, this is all the part, it can be years leading up to time zero. This is all the time within which you made your invention. While you were doing your R&D and playing around with your cooling system and fixing the way the angle worked between your arms, as you call them, and the seat in your assistive mobility platform, all the things that you had to do to come up with, okay, now it's ready. That was all done in this time before zero. Zero is the date you file your application. And that starts the patent prosecution clock. And the clock doesn't stop. You can't stop it at all. It keeps going. No matter what you're doing, the clock is still ticking. So you file your patent application here. You do some prior art searches to make sure you think it is novel and inventive. Otherwise, there's no point in filing. And you get an attorney to draft your specification and you file it at the patent office. You have 12 months within which to add to that, to make changes, to think of a different way to write it or to add something into it. You can write more things in that document up until 12 months. After that, you cannot. So in that time period, you have to reduce this to practice in a way that makes it work. Every time, no matter who does it, as long as they do it in accordance with what you've written in the document, it has to work every time. So it's reduced to practice, and you add more data to show the efficacy of your invention and support getting this much claim instead of this much. That's the 12 months. After that, if you just want to file in Sri Lanka, you can then file directly into Sri Lanka at 12 months. And then you go to examination. Eventually, I don't know how long your office takes. It might take a bit of time in here as well before it gets up to examining your application. But you don't have to worry about this segment in here if you're just filing in Sri Lanka. If you want to file internationally, almost everybody uses this route. This PCT stands for Patent Cooperation Treaty. And this is the major thing that is the work of the World IP Organization that runs this mentoring program. WIPO runs the PCT. They developed it. They have all the regulations surrounding it. They collect the documents. They send them to examiners. They do everything to do with the PCT. All of this international process up to national phase is all done by WIPO. And you file this document, the document that you finish at 12 months, you file it under the auspices of this treaty as what is called a PCT application at Geneva, at a PCT office in Geneva or somewhere. It goes eventually to WIPO. And in this time, between 12 and 30, you will get some helpful things. You will get an international search report, which might find 20 different documents that you didn't find when you did your prior art search, right? And it will give you a preliminary examination that will say all the reasons why your invention is not novel and not inventive, and probably it'll say it's commercially useful because that's generally not a problem. But inventorship is usually a big problem, and novelty is sometimes a problem, depending on what they find when they do their search, because they will do a search. And you will get a report, and that will come to you from WIPO. So this period here, this 18 months between 12 and 30, That's the international phase through the PCT. And it buys you time for Amali to find a commercial partner and negotiate some contracts. So instead of just having 12 months and then you go straight to examination and get a patent and have to pay the costs, you pay some costs here, but you buy this time within which to find a partner so that the partner pays the costs. And if you want to go internationally, those costs are very significant. So the university generally can't afford it. You generally need to find a partner to pay those costs. So if you get to 30 months and you still don't have a partner, and you've got lots of prior art cited against you, and you've looked at it, Kalana and Geet and Sampath, you've looked at it and you've assessed it and you've looked at your invention and you've looked at these documents. If you can't come up with arguments for why yours is novel and inventive on top of it to help Amali prosecute this, then it's time to say bye-bye, because the chances of getting it granted anywhere are going to be low. And to enter national phase, you're going to spend hundreds of thousands of dollars. I don't know what that is in your currency, but it's a lot of money. So you really need a commercial partner to decide where do they want to market this product, where is it worthwhile filing this application, and pay for it. So that's what this route buys you that time. As for publications, you cannot publish before you file. If you've published here, your publication is prior art against you and there's no way you can file. You must file before you publish. At 18 months, the patent will be published, because remember I told you that's the deal. It's published in return for getting the rights. That happens at 18 months, no matter what you say. So after 18 months, tick, 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 you can publish. In here, you need to think about it very carefully, because if you want to be in this commercial game, you don't want to prior publish yourself. And what can happen between 0 and 12 months is that you can make amendments to your invention. You can make improvements. You can find things that this is a better way to do it. I think I'll just tweak it like this. Okay? And you might want to write that into this document. But if you filed it at time 0, and whatever you filed, then you published at 3 months, okay? Or even worse, you make some improvements and you publish that at 6 months, and you don't put that in the document, and you put it in the document at 12 months when you come to do the PCT, you've already published it at 6 months. So basically you're screwed. You now have a document which is the same as your invention, and you have published it ahead of your invention. Because if it's different in this 12 months, different than what you did at time 0, you will not get the benefit of that filing date. You will only get the benefit of that filing date for the stuff that you've improved, the difference. So if that's the key, the different thing that you added in here, if that's the key to make it work really well, and you've published it in a journal article at 6 months, and then you put it in at 12 months, too bad. You published it before you filed. So that's why question marks here. Be very careful in this time period. Usually after 12 months, it's okay. And you can coordinate publishing your journal article with the publication of the patent, because it takes time to get a journal article published, right? That doesn't happen overnight either. Okay, so that's the process, and you can see that it can take quite a long time, because after you file, it just goes in the queue in the various patent offices in different countries, and you wait your turn, and then you get an examiner's report, and you get a certain number of months within which to reply, and then you wait another bunch of months and you get a counter report, and that gives you another few months in which to reply. So this examination process can take 2 or 3 years. Okay, so this is not done quickly. Okay, so that's the process. Now, thinking about the timing, thinking about this time here, when is a good time to make time 0? Okay, if you file too late and you've got a lot of competition, if it's a very hot area, like, I don't know, maybe cooling systems for batteries are a very hot area, because hybrid electric vehicles are hot topic now, aren't they? Not just hybrids, but all electric vehicles is a very hot topic, especially given the the COP26 and all of the stuff that's been happening in Glasgow for the last 2 weeks, the climate change issues, people want to stop the use of combustion-fueled cars or vehicles. So electric vehicles might be you might have a lot of competition. So you might not want to file too late in case somebody beats you with your idea. But if you file too soon, you run some risks. The risks are that you don't have enough data because you've only got 12 months. You have to file when you're pretty sure that you've got your final thing or that you can get the data within that 12 months. And then don't publish until you've got it in the PCT. And you might not have sufficient resources to gather the data. So you might think you can do it in 4 months, but then the person you wanted to hire takes 6 months to come and you don't get it in 4 months. So now the 12 months is up and you haven't got the data. And that means you won't get the breadth of claim that you want, and that means you'll fail. And there's really no point in filing a patent application that you know will not give you a decent commercial claim, because this is a commercial document. This is not a scientific document, even though the invention is science. This is a legal document that confers rights for a commercial entity to stop other people from making money so that they can make money instead, right? This is a commercial document. If the breadth of claim is not sufficient that they can stop other people, then it's not valuable and you won't be able to license it. So this is why timing is very important, very important. So people like Amali and Imoksha, I'm sure they've learned, setting the clock ticking is a very important decision. Okay, another thing to learn from the process that I've just shown you is that you have to be committed to this. You cannot just make the invention, write it up in a manuscript, write the patent, tell Amali at 12 months I'll submit my manuscript and then I'm going to do something else. Bye-bye. If you're going to do that, then Amali should say no, not file, because you are needed. The inventors are needed. The claim scope that you get is going to be directly proportional to the amount of data you've got. You might need to make more data over time. You can't put the data in the document because you can't add data after 12 months. But later, 5 years down the track or 3 years down the track, when you're arguing with the examiner about whether you had the invention in your head at the time, you can show other data to support the fact that you did. But if you're not generating that data, then there's nothing to show. So you can't file and forget about it. The value is proportional to the scope that you get, and the scope that you get depends on showing that you were in possession of the invention. That means that you knew exactly what the invention was and how it would work, and that it would work at 12 months. Not at 5 years when the examiner is reviewing it, at 12 months. You have to convince the examiner that at 12 months, you were in possession of this invention. So the data that you generate later can only support what you already wrote in your patent document. That's why the patent document is so important. Okay, so you need supporting data, preferably actual worked data, which in your case is easier. It's less easy in bioscience, but in the areas that you're working in, you're actually making prototypes of a thing. So this is more easy to do. You actually built the prototype. Here it is. Here's the real thing, and here's the description of it. Okay, so you need to be in this for the long haul. If you're not in it for the long haul, then just do your science and publish your papers and don't try to work with Amali. But if you are interested in actually trying to make this commercial, then you need to be in it for the long haul and work with her together and Imoksha to make this happen and be committed to helping for a number of years. Okay? So next month, we'll talk about this question. Should I? We've talked about what is the patent, how do you write it, what does it look like, what do you get, what does it allow you to do, what's the process for getting it? But the big question is, should I bother? What have I got? Should I bother going through this process? So we'll talk about that next time. I have a series of slides to show you next time about this topic. This is what it will cover. The value. And you'll notice that these are the things Some of these things are in the 10-point assessments that you did, right? What is the invention? Is it patentable? Can I get a patent? Is it inventive? Those are the first two things in your 10-point assessment. Is it worth it? If I could prevent others from making it, would that have value to somebody? Is there a market? How big is that market? What's the scope? Is it easy to work around this or not? If it's easy to work around it, nobody will want it. They'll just work around it and not pay for yours. If it's a method, this is not so relevant for yours, but if it's a method like mining site remediation, where you have to do steps 1, 2, 3, 4, 5, is it possible to detect if somebody else is using that method as opposed to a different method? Because if you don't know they're using your patent, you can't sue them for infringement. So you need to be able to detect that somebody's using it. With a device, a piece of equipment like you guys, it's a lot easier. Okay, a lot easier. And how likely is it that somebody would infringe? So this is also, again, to the market. How does the market work? Who's in the industry? Are there competitors or customers and suppliers who would want to use this and who would need a license? Because if they don't have a license, they'll be infringing. Okay. Those are the things that you need to talk about, and we'll talk about them next time in our next seminar. So the last thing I want to just tell you quickly is about who are inventors. And this is important for you guys because it goes also to the policy, which Amalia was kind enough to send me. So we can talk about in a few minutes after we go through this. There's only 2 or 3 slides left. So the invention has to have a thing called conception and a reduction to practice. That means somebody has to have dreamed it up, okay, intellectual property, you dream it up, and then you make it work. That's what those two things are. To be an inventor, you have to have contributed to one, either the conception or the reduction to practice, or both. If you just made it because somebody told you how to, you're not an inventor. You have to have actually thought about the idea. So inventors of correctly the actual invention and how to make it work, how it would work in practice. It can be joint because sometimes you talk to more than one person. So I think, Kalana, you and Geet talked about it, and you had other people listed as inventors. I query whether they're inventors, okay, but we can come back to that later. You have to be the person who dreamed up the idea. I think that was Geet, and or the person or people who made it work, made it happen, overcame some hurdle to make that thing become a structure, become something that works according to how it was dreamed up. So sometimes it's more than one person, okay? But and be more than an extra pair of hands under instruction. That's not enough to make you an inventor. You have to have creative input into making it work. Maybe you identify the way to overcome something that it's in the way and it's not working. Why is it not working? Aha, I have an idea. Let's do this. That makes it work, right? Then the pair of hands might be an inventor. But if they're just doing what the person who conceived it tells them to do and build it in accordance with that concept, that's not invention, okay? This is very important. So the inventor is the person who has a definite and complete conception of the invention and can tell somebody else how to do it. It's not equal to authorship. If you write a manuscript, you sometimes get material from somewhere else, or the people in the lab that help you do it get their names on the paper because they helped, they contributed. They're contributors, but they're not inventors, right? So you have to think of these things as different. It's a legal issue, and it has to be determined legally, and it has to be determined after the invention's made. You cannot decide up front before you do it who the inventors are, right? Because it can change over time. And remember, the claims might be 5 years later, and the actual inventive thing in the claim there might have been 2 or 3 things that you had in your specification, but maybe one of them isn't inventive and it's thrown out, and you get a narrower claim, and therefore it's just these things that are in the claim, and this person that came up with that bit is no longer an inventor. So they have to be changed. It can change over time. They have to be correct, because if it's wrong, it can cause the patent to be invalid. So it's very important that the inventorship is correctly determined. Okay, so next time we're going to talk about this, should I patent? And that speaks to, not its inventorship, that speaks to this, what's the value? This is what we'll have at a later seminar. At the beginning, there's no value, right? It only creates value if somebody wants to make it and make money on it. And to do that, you need to write runs to do it yourself. How do you do that? And in exchange for what is going to be in other seminars later. Okay? Any questions about all this? It's all very basic.